Ever wondered how meshes are created in OpenFOAM? Today we will explore blockMesh, one of the most fundamental meshing tools in OpenFOAM. Hello everyone, my name is Mukul Chandra and I welcome you all to CFD Simplified, where we break down complex CFD concepts into simple practical tutorials. If you are interested in OpenFOAM and CFD, make sure to subscribe. Alright, so I'm just explaining you by converting the blockMeshDict file into the PDF because I want to make some figures, and through that figures I thought that I will be explaining in a much better way. So that's why I converted that blockMeshDict file into the PDF. Okay, alright. So this is our blockMeshDict file. I'm just right now skipping this scaling one. I will explain it afterwards. Okay, so now let's start with vertices. What is vertices? Vertices, basically the meaning is the same. Okay, these if you want to draw a rectangle, so these is called as the vertices of the rectangle. Okay, so that we all know. So how to give the length to these vertices? Okay, so if you wanted to make anything, any type of box or anything, you have to give the length in the form of the coordinates. What I have told you, like coordinates means like you have to define the points. Okay, the points in the vertices, basically we give the coordinates, so it define the points here. Okay, and after that it makes the it generates the mesh. Okay, from that. Okay, so like for example, here the first point is 0 comma 0. So if I'll take the coordinate axis as this is x, this is y, and this is z, so I'm considering this as origin. So the first point is 0 0 0, the next one is 1 0 0. Okay, so this one I'm considering it 1 0 0. Okay, x, y, and z. Third one is 1 1 0, so this one, and the fourth one is 0 1 0. Okay, this one is. Now the fifth one is the coordinates in the z-axis. Okay, so z-axis is means like it is 0 0 0.1, and here it will come like 1. Okay, let me bring it to the center, just a minute. Okay, so it will be like 1 0 0.1. here it will be 1 1 0.1, and here it will be 0 1 0.1. Okay, so let me make the three rectangular box. Okay, so this one is the back side, we can say, and yes, this one is the front side, we can say. Okay, all right. So if we divide the rectangular box into front and back, so the front one, which is having the z-axis coordinates, is considered as the front, and the back one where z-axis coordinates are 0, we are considering it as back. Okay, so one thing you should know, that OpenFOAM is a 3D software. Okay, is a 3D software. Okay, so you have to make each and every model, you have to make it in a 3D form only. Okay, like what happens is, like in this example which we are taking, this is the same example which we have done in the first simulation video. Okay, like running your first simulation in OpenFOAM. Okay, so that example is doing the analysis only in x and y, means like it wants the value in x and y direction only, which means that the analysis is mainly focused in the 2D analysis, it is. Okay, but as I've told you that OpenFOAM is a 3D software, you cannot ignore the z-axis. You have to give the value to the z-axis. Okay, even though if you for example, if you like make it till here also, okay, like you cannot give only x and y coordinates, this so you cannot give. Okay, you can also not give the value till here. If you give the value keep 0 0 0, it will again consider it as 2D only. Okay, you have to give this value, this is some value in the 0 point in the z-axis. Okay, because if you give some if you do not give, it will show you some error. All right, that is what I wanted to tell you. So this is the way you define the vertices, you define the lengths in the form of the coordinates of whatever you wanted to make, whatever model you wanted to make. Okay, and if you wanted to do a 2D analysis, what generally a CFD people do is like in the which are using OpenFOAM, like they give a very small value in the z direction. Okay, so that very small value can be considered as negligible. Okay, and we only take the analysis in x and y direction. We don't have any consideration what is happening in the z direction. Okay, we just give the value to the boundary condition to the like the in the z direction. We consider it as empty. I will explain it in the below, because boundaries also we are defining it here only. Like if you do the analysis using ANSYS Fluent or any software, you have to define when you make a 3D model, you are defining like what is the, where is the inlet, where is the outlet, and other boundaries you are considering it as wall. So here also we have to do it like same. Okay, yes, these are the things. So in this way you define the vertices. All right, now now let's come to the block section. Okay, removing this. Okay, let's come to the block section. So what is the block section? Block section is like, if you by making this, what you have done, you have made an sketch. Okay, like you can say that you have created the outer boundary of your 3D model. Okay, now these blocks will make the small hexagonal boxes inside it, and that hexagonal boxes make your mesh. The combination of these hexagonal boxes makes your mesh. Okay, like what is this? If there is an hexagonal mesh, okay, like this, okay, like this. So what is this? It is the combination of the number of hexagonal boxes. Okay, in like this is one box. Okay, this is one box, this is one box. This is like, let me change the color, or let me do it with the laser one. So this is one box, 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 this is one box. So these are the boxes in x direction, similarly in the y direction. Okay, so you can control those boxes by giving the values here. Okay, by giving the values here. So what is this 2021 means? Okay, this 2021 means this first 20 is number of, like I will note it in the short form, nx. This 20 means ny, and this 1 means nz. Okay, so nx is number of boxes in x direction. Okay, ny means number of boxes in y direction. Okay, and nz means number of boxes in z direction. Okay, so this is the thing which this 2021 means. Okay, like how many boxes you want in x direction. So if you count, if I will show you in the in paraview also, like if you count in x direction how many boxes are there. So if you will count, it will come at like 20. Like this is the drawing which I have made. Okay, but actually what number of boxes, we will count it simultaneously and we will make it. Okay, similarly if you count it in y direction, it will be the same. Similarly if you count it in z direction, it will be 1 only, because we want it to be 1. Okay, we don't want any fine or any coarse mesh in the z direction. We don't have anything to do in the z direction, because we are not considered anything, because we are doing a 2D analysis. We want to do a 2D analysis. Okay, that's why we have given 1. If you wanted to do that a 3D analysis, then you have to be consider this, and then you have to if to make a proper mesh, you have to give the proper value here. Okay, a proper value here. If you want if you are doing a 2D analysis, then one you can consider 1. Okay, so why they have written 2020? So that depends on the mesh, the coarse mesh or fine mesh, the way you want. Okay, like the proper mesh you want, so that depends on that, by the combination, by the length and everything they have considered. So 2020 was becoming the best fit, so that's why they have considered the value 20 and 20 in the x and y direction. If you want a finer mesh in the y direction, okay, then you can increase the value of this, so it will make more smaller boxes in the z direction. Okay, if you can more horizontal line, so you can, if you will count, then it will the in the x direction the number of boxes will be 20, but if you will count in the y direction, the number of boxes will become 30. Okay, similarly, if you want to make the finer mesh in the x direction also, you can increase the value to the 40. What it will do, it will make the finer mesh in the x direction also. You will count it and you will find that the finer mesh, the mesh is 40. Okay, the number of boxes in the x direction is 40. Okay, so so like this, you, if you want to make finer or coarse mesh, you have to play with nx, ny and nz. Okay, now how to decide it, that depends on the project, on the model, on the size, on the shape, what you want, what you are generating. All right, what you are generating, so that depends on that. Okay, I'll be looking afterwards, and if I'll find some good problem, then we'll be making one mesh by our own. Okay, and then I'll be telling you that, okay, like how we are gonna decide these nx and y and nz to make the perfect mesh. Okay, there I will be telling you the same. Okay, so you have got this part. Now comes the these. What is this? Hex 0 1 2 3 4 5 6 7. Okay, these are the numbers, are the names, basically are the numerical names which has been provided to the vertices which we have defined here. Okay, so means like this one is the 0, this one is the 1, this one is 2, this one is 3, this one is 4, this one is 5, this one is 6, and this one is 7. All right, so like you can say that why I am making two forward slash lines here, because this has to be comment down. Okay, this is, if you write simple, if you write simple 0. Okay, if you write simple 0 here. All right, so sorry, the OpenFOAM, and you run the blockMesh command, it will give you error. Okay, it will look like, what is this? Okay, so the naming you can give or you cannot give. OpenFOAM automatically consider this one as 0, this coordinate as 1, this coordinate as 2. Okay, second, this coordinate as 3. Okay, so OpenFOAM automatically considers that, but for the good practice, I prefer to give the namings here. Okay, and you have to comment down this. So for the comment down, you have to make two forward slash and then 0. Okay, this is the way you can define the namings. Okay, so you know about this is 0 1 2 3 4 5 6 and 7. Okay, this is the thing you have named. All right, so in each and every vertices, I want this only. Okay, I want this only. Okay, for example, this was our rectangular box. Okay, this was a rectangular box. So this one is named as 0 1 2 3 4 5 6 and 7. Okay, so in the front and in the back, we want the same number of boxes in x and y direction. Okay, for example, if you want to make the front one finer and the back one the coarse, okay, so you can define it in other way, like you can write it like hex, okay, 0 1 2 3. Okay, and you can make it as coarse one. Okay, so I'm considering this one. Okay, and you want the back the front one, as the front one coordinates are 4 5 6 and 7. So 4, 5, 6 and 7. So this you wanted to make like 50-50. Okay, so 50, 50 and 1. Okay, so you can make it like this. All right, you can make it like this. Another thing, like if you want to keep the same, you can all write all the names, numeric names of the coordinates, all the numeric names of the coordinates in a single line, and you can give the number of the boxes, and you can write the simple grading also. I will explain about simple gradings also soon. Okay, so this is the thing. Now one more important point is here. Okay, how we are defining this. Okay, OpenFOAM always make the boxes like inside boxes which I have defined. It is always making the boxes like this, either in clockwise anti-clockwise direction or in clockwise direction. Okay, did you get it? Either in the anti-clockwise direction or in the clockwise direction. So it will not make the diagonal. Like for example, if you have given the naming, like how I have given, okay, how I have given the naming, like I have given the naming, like if you wanted to make the finer mesh. Okay, let me go backwards. Yeah, so for example, you can see that here I have given the naming like 0, 1, 2, 3. Okay, like these are at one side only, and 4, 5, 6, these are at one side only. We cannot give the namings diagonally. Okay, we cannot make the blocks diagonally. Like if you want to make, if you have given the naming like 0, 5, like it will be like this: 0, 5, 6 and 7, 0, 5, 6 and 7. Okay, it will give you error. It will definitely give you error, because diagonally it will never ever it will make the diagonal boxes. Okay, it will always make the boxes like this only. So in the hex, you always have to give the namings like this only, like 0, 1, 2, 3. Either you can give it in the clockwise direction, anti-clockwise direction, or you can give the naming in the clockwise direction. Generally you will find in the OpenFOAM tutorials also, you will find that the namings are being given in the hex one, the namings have been given in the anti-clockwise direction only. Okay, so this is the thing. Now comes the part of simple grading. Okay, what is this simple grading? Okay, so I hope you have understood the things. Okay, so make sure the naming of the coordinates, you do it in a good way. You can give the name and any name here. Okay, that is fine. That is fine. Like you can give this one as 0, this one as 2. Okay, no, you have to give it like this only, because it will now afterwards, because it is automatically considering it like that, so it will give you error. But here you have to make sure that here you are giving the naming in the either in the clockwise or in the anti-clockwise. Do not give the naming in the diagonal form. Okay, I hope you have understood that part. Okay, fine. Now comes to the boundary part. Okay, now comes to the boundary part. What is okay, before boundary, simple grading is there. Okay, so this is simple grading. Okay, simple grading means like 1, 1, 1. Okay, so simple grading means the spacing, if it is 1, 1, 1. Okay, so the spacing between the number of boxes is same. Okay, the spacing between the number of boxes in the mesh is same. Okay, is same. Okay, like this is 1, 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 and this is 1. Okay, here in the y direction also it is same. In the y direction also it is same. Okay, it is same. Now you want to make something, you want to do something something more, because in the complex projects it is required to be done. What you want to do is like, you want to make first very thin, finer, and then it will kept on increasing and increasing in the x direction. In the y you will keep it same. Okay, so what you can do, you can give the value greater than 1. This is like x, y and z only. If you want to make in the x1, like finer in the starting, like the distances, the delta x, like we consider this as delta x, like you want this delta x to be increasing. Okay, so in the increasing format, so if you want to make it in increasing format in delta x, then you have to give the value of x in the simple grading greater than 1. Okay, same, if you want to make the delta y increasing, same, you have to give the value greater than 1 in simple grading in the y position. Similarly, in the z1, if you want delta x to be decreasing, decreasing means bigger in the starting and then becoming finer in the end. Okay, so you have to give the value of the delta x or delta y as less than 1. Okay, as less than 1, like 0 0.1, 0 0.2, 0 0.01. That depends on your case. That depends on your case. So this is basically simple grading means the how much, if you want to keep the equal delta x, okay, equally spaced delta x, delta y, delta z, you have to give the value of delta x, delta y, delta z is equal to 1. If you want to make the mesh finer or coarse, then you have to give the value accordingly, which I have what I have told you. Okay, so this is basically defining the spacing in the x, y and z direction. Okay, in between the blocks. Okay, that is the thing. All right, so next one is the boundary part. Edges, you can generally edges is not defined. Okay, it is, you can rarely see the definition of these edges. Basically, edges is like you are just defining what are the edges. Okay, what are the edges of your mesh basically. Okay, so generally in OpenFOAM we complex geometries, I've not seen in the complex geometries also that edges are being defined. Okay, if it is defined, I will just look into it. I've not come into touch with any of that, but if I'll come, I will just make a video on the same and explain about the edges also. Okay, now comes the boundary. Like I have told you that when we create a 3D model in any of the 3D software, we are just defining it, like what is the boundary, what is the inlet, okay, what is the outlet. Okay, so we are just defining inlet and outlet. All right, so here also we will be doing the same. Okay, like and how we will be defining it. Okay, so let me show you that. Let me make the rectangular box again. Okay, this is our rectangular box. Okay, so this one we are considering this one as inlet, this one as inlet we are considering. So let me name it. So this is like 0 1 2 3, this is 4 5 6 and 7. So like here they have not considered it as inlet. So like, okay, I will tell you. Okay, so if you are considering this as inlet, okay, so how we can define it? We have to define it in the like in the clockwise and anti-clockwise manner only. So like if you are defining as inlet, okay, if you are defining as inlet, okay, so the coordinates will be given as faces, will be writing faces, and will be defining it as, giving the name here inlet. Type we will write here as inlet outlet. Okay, inlet outlet or patch, both we can write. We will discuss it in later on at what type of boundaries we can define it in the OpenFOAM. Okay, that is different part, don't go on that. I'm just telling you how to define it. Okay, so and we'll be defining it like 0 4 7 and 3. So like this, like this, you have to give the namings of the inlet, that it will define that this portion to be considered as inlet. Okay, so here they have given it as like they are considering moving wall, fixed walls. Okay, so this one they are considering as the moving wall. Okay, so how they are defining it? 3 7 6 and 2. Okay, you can see that it is they are doing it in the anti-clockwise direction only, and this one, the top face, they are considering it as the moving wall, and they're defining it as 3 7 6 and 2. Similarly, the fixed walls are this one, like which area? This one is the 4. Okay, so this area is the fixed wall. 2 6 5 1, this one is the fixed wall. I think, and 1, 5, 4, and 0. Yeah, this one is the fixed wall. Okay. So all the others, okay, side, all both the side one and the down one, these are the fixed balls. Okay, and they have defined it accordingly. Like the side ones is like this one side one, so 0, 5, 0, 4, 7, 3. This side one is like 1, 5, 6, 2. I hope. Okay, so 2, like it is, okay, they have defined like this, 2651. Okay, 1540. So this is 1540 is 1540. Okay, so they have defined it. Okay, and about the front and back, I have told you that whenever you are doing a 2D analysis, okay, but we have to define the model, the mesh in a 3D mode. Okay, so you can make the front and back and give the type to be empty. Empty means these are not participating, these are not participating in the analysis, in the simulation analysis. Okay, but we have to define it. Okay, otherwise it will, OpenFOAM will consider it or will give error. Okay, most of the time it gives error only. It does not consider it like it does not consider it like some like automatically something. Okay, like in ANSYS, if you it does not define anything, ANSYS try to consider it as solid wall. Okay, but here if you do not define it, it will ask you, if it will give you warning, or in some cases it gives you error. Okay, it gives you error. So that's why we are considering this front and back as empty, because we don't want the analysis to be done, so we can consider it as empty. Okay, so like this we define our blockMeshDict file. Okay, I know the video has become longer, and something, there were many things, but this explanation will give you an overall idea, like how the things will be defined. Okay, okay, so now let's talk about this scaling. Okay, what is this scaling part? So basically with this, scaling is about, like, for example, you have got some problem to do. Okay, so for that problem you need to make the mesh, but the thing is that the dimensions which has been provided to you is very large. Okay, like for example, it is 10 meter into 10 meter. Okay, you may think that 10 meter is a very small, and it may be. Okay, I don't know about that. With respect to if I'll talk about the generating the mesh, okay, with respect to it, may be a very normal dimension, but I'm considering that it is not a normal dimension. Okay, why I'm saying it is not a normal dimension? Because this is a very 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 big box. Okay, very big box. And if you wanted to generate the like when we try to make any mesh, anything, so we try to make the mesh as small as possible, as compact as possible. Okay, because making larger mesh means number of nodes will be more, and number of nodes will be more, so it will be making the mesh very heavier, plus simulation will take much time to complete, and it will be taking using our resources, our CPUs, very much. Okay, so good CFD engineers try to make the mesh as compact as it can, and try to include only those area of the model which will be which are important for the analysis. Okay, only those areas, not any extra areas, like, okay, we can just keep it like this. Okay, so for example, you have got this, and the dimension has been given as 10 meter into 10 meter, and you thought that, no, I have to make it small. Okay, so how you can make it small? One thing you can do, like, in a very simple thing, you can do it like, okay, I will just make it like 5 meter or 5 meter, or 1 meter or 1 meter. Okay, like, you in this case you can do, but in the complex cases you cannot do that. Okay, so at that point one terms come into play, and that is scaling. Okay, scaling helps you to make a model short, or if you want to make a model large, you can make it large also. Okay, so like if you want to make model 10 times smaller, okay, so what you can do, you have to divide the dimensions by 1/10. In OpenFOAM you cannot divide anything. Okay, OpenFOAM doesn't take any division, it only multiplies. Okay, so you have to convert it into the decimal number. So 1 by 10 becomes 0.1. So it will, so now the dimension will multiply it by 0.1 into 0.1. So now the new dimension will become 1 meter into 1 meter. Okay, so you have to give the original dimensions here, original units here in the vertices one, and you can give your scaling value in the scale part. Okay, so it will be make the, sorry, it will make the your mesh smaller. Okay, so you have to, you can do, or if you wanted to make it larger, in some cases it has not happened till now with me, but if in some cases it may happen that you wanted to make it large. Okay, so what you can do, you can give the value here in the scale greater than 1. You want to make it 1, for example, you want to make it 10 times larger. Okay, so 10 times larger means give the value here 10. If you give the value 10, so 10 will get multiplied with this, so this one become 100 into 100 meters. Okay, so that is what I wanted to tell you. If you want to make your scale your model down, or your scale your model up, you have to give the values here. But the main thing you need to remember, that if you are giving the scaling value, some scaling value other than 1, so then you have to give the original dimension here in the vertices. You cannot do it like, okay, you wanted to make a smaller one. Okay, you know it, one simple geometry you are having, and you wanted to make it smaller one. Okay, so you have calculated it manually and you have got the dimensions. Okay, I will keep the dimensions 0.1 and 0.1. So here also you are giving 0.1, and in scaling also you are giving 0.1. So it will make the your mesh more smaller, and that is not required. Okay, that is not required. So you have to take the optimum size. Okay, so for the optimum size you have to make sure. Okay, if you are having the knowledge of like how much I can decrease the dimension, you have calculated manually. So in that case, what you can do, you can give the scaling value here 1 and smaller dimension value in the vertices. Okay, then it is fine. If you wanted to but giving both, doing both the things is not fine. Okay, so that these are the things which you have to keep in mind, keep in mind and take care of very carefully while making the blockMeshDict. Okay, so these were the things I wanted to explain about blockmesh file. Okay, in other video I will be making one mesh, and that there I will be showing you like how I am just increasing the values and making the mesh finer or coarser. Okay, so in the next video mostly I will be just doing the same thing. All right, so now you know how to create a mesh in OpenFOAM using blockMesh. If this tutorial helped you, hit like and subscribe for more CFD videos. Let me know in the comments if you want tutorials on Snappy Hex Mesh or other OpenFOAM features.